Material parameters of structural members. Define a material data set for plate elements simulating the shoring wall. Unit weight of the shoring wall to be calculated separately. The same is for axial and bending stiffnesses. They should be calculated separately. Let's calculate material parameters of plate elements simulating steel sheet pile wall. Take unit weight of the sheet piles directly from manufacturer's technical data sheet. Just don't forget to convert the units from kilograms per square meter to kilonewtons per square meter. Axial stiffness of the wall is calculated by multiplying the Young's modulus of steel and the cross-sectional area of a running meter of the wall. Bending stiffness is calculated by multiplying the Young's modulus of steel and the moment of inertia of a running meter of the wall. Assign calculated parameters to the data set of plate elements. Mu is the Poisson's ratio of steel, which is equal to 0.3. Define a material data set for anchor elements simulating free length of ground anchors. Node-to-node anchor elements have two parameters, out-of-plane spacing and axial stiffness. The latter is calculated separately. Calculate material parameters of anchor elements. Spacing of the anchors should be a multiple of the spacing of steel sheet piles. Use spacing of 2.25 meters. This means that anchors will be installed in every third steel sheet pile. Axial stiffness of the anchors is calculated by multiplying the Young's modulus of steel and the cross-sectional area of thread rod of the anchor. Assign calculated parameters to the data set of anchor elements. Define a material data set for embedded beam elements simulating bond length of ground anchors. Unit weight for ground anchors is usually ignored due to a small value. Stiffness modulus should be calculated separately. Parameters of axial skin resistance should be calculated separately too. But for our example, use random values that are high enough to provide sufficient anchor skin resistance. Calculations of the actual skin resistance of ground anchors is out of scope of this course. Parameter, base resistance is not applicable for ground anchors. Calculate material parameters of embedded beam elements. Out-of-plane spacing of embedded beam elements should be equal to the spacing of node-to-node anchor elements, simulating free length of ground anchors. So, use the spacing of 2.25 meters as it has been selected before for node-to-node anchor elements. Stiffness modulus is calculated as for a composite member, including steel thread rod and grout body. Assign calculated parameters to the data set of embedded beam elements. Click the left mouse button on the plate element and assign a material data set to it. Click the left mouse button on the line denoting the free length of the ground anchor, and create a node-to-node anchor element. Click the left mouse button on the same line again, and assign a material data set to it. Click the left mouse button on the line denoting the bond length of the ground anchor, and create embedded beam element. Select the embedded beam element, and assign a material data set to it at the Selection Explorer window. This is an alternative option to assign properties of structural elements. Also, set the behavior of the embedded beam to grout body. Extend the left boundary of the model by 10 meters to the left, to eliminate boundary effect on the ground anchor behavior. Create a line load of 20 kilopascals at the ground surface behind the shoring wall. Save changes made to the model.